greetings from Aegis India. This is your webinar host, Mr. Nagarajan. I am from Business Development Team at Aegis India. Thank you all for coming online to attend this webinar on improving design productivity using SolidWorks. Before we begin, a quick note. To ensure a smooth experience for everyone, we have disabled your cameras and audios to manage bandwidth constraints, but don't worry, you can still engage us with through the chat and question answer session at the final. Now let's get started. In our daily life as an engineer who create products, we end up spending our time in non-valuable, added and repeated tasks. Taking up our business products or our professional skills to the next level requires time. Right? Tools like SolidWorks would help you to do the same. Maybe you are an existing SolidWorks user, or you can be a new to this community. This workflow, which we are going to look today with SolidWorks, will help you to hone your skills, increase innovations and productivity. Over the next 40 minutes, we have Mr. Natarajan Ramamurthy, Managing Director of Aegis India, to present on the topic of the day, improving design productivity using SolidWorks. Mr. Natarajan has over 36 years of experience in product design, infinite element analysis and design verification, validation and development, and etc. His scores on FEA are well known in industry and academia. He has done a master's degree in mechanical engineering from the University of Toledo, US, and started his career with Ford Motors Company in Ford Scientifica Research Laboratories. Before moving on to Alphia Simultaneous Engineering Divisions to work on new product design and development, incorporating emerging technologies in automotive engineering. He also has worked on development of product designs for braking systems, suspensions, instrument panel support structures, full vehicle systems with using simulation tools as mainstay in a design verification. An ASME certified GD&T technologist, and he has been incorporating with GD&T practices in product design and development in addition to consulting with industries in varied vertical segments. He is also an active member of Bureau of Indian Standards with MED sections, assisting in involving standards for material handling equipments in addition to the drawing standards committee. We will have a dedicated question and answer session finally, but if you have any questions in between the session, kindly type it in a chat box. Now I invite Mr. Natarajan to take over the webinar to present his views on improving design productivity using SolidWorks. Thank you.
Thank you, Mr. Nagarajan. Natarajan here from Aegis India. It's exciting to be with the young community of design engineers who work across many different products and technologies in India to engage on this 40-minute session on how to improve the design productivity using SolidWorks, the mainstream CAD software that people use across many varied industries in India. One of the most important things about productivity is it's not measured based on the number of drawings we release. It's not based on the number of 3D models that we create. It is primarily related to how many different products and technologies we have developed, which are unique, which are helpful for the organization in terms of cost, time, and quality, and also in terms of the market capitalization for the organization. That, if it is done effectively, the management as well as the end consumers of your products are able to appreciate your efforts. Over the next few slides, you will be seeing. Let's go through the agenda. First, we'll start with the brief about Aegis India, and then delivering product designs, the different mechanisms in place, and the simple steps that we need to have for productive designs to come out, and then we will end with a Q&A session. As we go through this presentation, I want you to focus on the processes that we are emphasizing upon, which the tool helps us to enable to achieve end purpose for the different products and technologies that we come up with. Aegis India was started with the vision of engineering development through effective partnership with customers, imparting leading edge technology through training and development is our mission statement first, resolving problems and new product development through consulting services, which we have been doing since 1993, forms the second aspect of our mission. And third one is providing software solutions and technical support in conjunction with Dassault Systems, SolidWorks Corporation, across different varied segments in India since 1999. Our timeline is we started from our US operations was started in 1981, AGS Incorporate USA out of Greenfield, Michigan, working as a tier one design supplier to Ford, General Motors, Robert Bosch Corporation, so many different companies working on vehicle engineering systems. We started AGS India in 1993 after I returned from my US operations and having worked at Ford. And then in 1996, we started our academics training division, followed by representation for Cosmos Finite Element Softwares in 1997, which was acquired eventually by SolidWorks Corporation, as a result of which we became a representative of SolidWorks in India since 1999. And we started the AGS operations, started independently in 2002. And we had our first operations in Coimbatore outside of Chennai in 2007, followed by Trichy operations in 2009. We moved to our own facility in India in Chennai in 2011. And we have developed quite a few softwares ourselves, like which was launched in 2023 with one of our customers, a Japanese customer. And then we have developed and we are launching shortly the product called the Live QC tools, which is specifically for the quality control people. This is where we are. And since 1993, 31 years of product engineering experience working with OEMs and tier one and tier two suppliers, automotive and non-automotive, with over 140 strong engineering team. Actually, it has crossed 150. And we have 3 branches, the main one being in Chennai with the significant operations in Coimbatore and followed by Trichy. And our presence is across varied segments with over 2,000 customers. We are affiliated with the Bureau of Indian Standards in developing new standards, upgrading the existing standards used by the industries, specifically in the area of material handling equipment with IS 807-3177, which got amalgamated with heavy engineering standards, and then followed by the PGD 25, which is for the drawing standards. And then SAE India, our affiliation goes very long. IMTMA for the Tool and Machine Tool Manufacturers Association, IPI for the Plastics Institute, MMA for the Management Association, and NIQR for the National Institute of Quality and Reliability. Our forte is development of unique designs based on cost, time, and quality paradigm that we have been helping customers with. Our business model comprises of 3 different vertical segments, namely engineering services, where we do the product design and development, design validation, dimensional management using GD&T, tolerance stacks, and forth, and value engineering and value analysis. On the software side, as I told you earlier, we work with SolidWorks and the Simulia brand for the nonlinear finite elements, and the PDM PLM from offering from Dassault Systems. In addition to that, we have the Live PLM, which works with the SolidWorks PDM, and we have the indigenous product called as the Live QC tools, which is specifically for the quality management system. Technology training provided through academics is primarily known for courses, the geometric dimensioning and tolerancing courses, and the tolerance stack courses. The FMEA, with the latest standard coming from the FMEA, designed for manufacturing and assembly, and popular CAD and FEA tools. Why we are here today is specifically the productivity for the design teams, how to improve productivity, specifically to the SolidWorks. Productivity, more with less is, in other words, more output with less input. Error-free nature of drawings that we produce, error-free in terms of the design itself, and cost effectiveness, and the shortest time possible. This is what we look at. These are the definitions of productivity that we bring in about. Now, when we look at the type of design activities that we do, there are 3 different kinds of design activities that we do. One is the derivative designs, where we take a family of products and extend it, keep producing new designs from the existing designs. The next one is the evolutionary design, where we take a design and we modify it, and over a period of time, the design transforms itself. It could be a completely different design. However, nevertheless, the mother of that design is the first design that you started with. So it evolves over a period of time. The third one is nothing like that before, innovative designs. It could be a combination of these three in any particular project that we are working with. In other words, if we emphasize on the productivity with regard to the derivative designs, with regard to the evolutionary designs, and also with regard to the innovative designs, then we hit the goals in all the three areas so that the bullseye is hit upon and we become productive day in and day out. Because continuous process improvement is something that ISO 9000 2015 emphasizes upon, in addition to risk mitigation, which we'll be going through in the next few slides. The action on what to automate or how to improve productivity depends on the assessment with regard to quite a few challenges that we face in our day-to-day activities. The assessment has to be on the following lines, namely, how much of the effort is repetitive? How are the downstream errors need to be eliminated? Are the processes standardized? Are automated checklists used to verify compliance before sign-off? These are a few questions. There are endless questions which we need to keep adding upon, but these are significant that can impact the cost, time, and quality. As a result of which we need to address this if we have to look at design productivity. If a person releases a drawing, let us say within an hour, but it goes through 3 to 4 engineering change requests because of errors in considerations and output of the drawing over the next 3 weeks, and the tooling gets delayed, the supplier engagement gets delayed, then it is design productivity which is at an issue. So in other words, the 1 hour time taken to release a drawing is no longer the focus. It is the correctness of the drawing specification which comes into focus. So we cannot afford 3 days delay or 4 days delay post drawing release, because it brings the entire cross-functional team's activity to a standstill. That's where productivity suffers. So this productivity leakage is the white elephant in the room, especially in the R&D sector, in the design and development sector. The white elephant that we don't see. Why? Because delay is the norm. So if we have to shift this paradigm, then we need to look at the assessment of how many of these questions need to be answered and how effective those answers are before we proceed further on improving the productivity. Now, a lot of times designs are driven using standards. They comply with standards. It could be statutory requirements as well. But nevertheless, the standards driven design are easy sitting ducks for automation. Capturing the design knowledge becomes easier, error proofing of drawings becomes simpler, and template driven designs become easier to implement. Take, for example, this case. What you are looking at is an expansion joint design. This is based on the EDGMA standards. The EDGMA standards stipulates quite a few design calculations that need to be embedded. Now remember, imagine you are the manufacturer and the supplier of this expansion joint to many different customers across various applications. Now imagine your salesperson sitting in front of a customer and discussing with him or her the requirements for their project on hand. Now the person on the other side gives the specification what they need, and it could be one expansion joint, it could be hundreds of expansion joint, especially if it's an chemical plant expansion or things like that, Then the person sits there, goes through the calculations which are sitting over there embedded into the system, creates the RFQ and the drawing from the menu interface that you see here, and he brings about the drawings and provides it to the customer through a workflow inside the organization based on this front-end tool. and he releases the drawing to the customer with essential calculations, the design data that the customer needs to know, all without input or interface with the design team, because this is non-value added activity as far as the design team is concerned. The GA drawing goes to the customer. The GA drawing instantaneously gets approved. The customer looks at the whole experience of getting a proposal right at his table when he is sitting and discussing with the supplier to be the details of the project, and the person gets the proposal at the end of that meeting, even before the minutes of the meeting has been provided. This is called as design productivity, because the design person is the invisible person in that room who is effectively doing all these works because he has automated it. The benefits are capturing reusable knowledge. It transforms from person-specific activity to process-centric, meeting the customer requirements process. Error proofing of the drawing so that the GA drawing gets vetted out and given to the customer, and no errors are there, so that the drawing gets attached when the order comes in and no further corrections are required on that. And these are template driven designs. So when we go through this kind of a process, this is one area where we need to look at it from the end, where the RFQ comes in, till the end, where the invoice goes out, how to automate the design functions so that non-value added activities can be reduced, as a result of which the productivity of the organization enhances exponentially. Look at this example, wherein one of our customers, we just did this, the proof of concept for a customer. It is basically for a nozzle in a pipeline. You go through it, you look at the nozzle dimensions, you give the dimensions, whatever you want, give the default values, generate the 3D model, and the 2D drawing gets generated right then and there. The nozzle sections, the edge preparations and other things can be brought in from the sketches which are kept in the design library. You can bring it in and you can pull it and you can put it over there. And every time those design sketches change, the drawings will change. No intervention is required. You put this together, you get to see the complete nozzle drawing coming out in one step without touching anything. And this was written using the SolidWorks macro. What you saw was the macro getting executed. This could be done at the salesperson's level. This could be done at the customer's level itself. If you give it with a web interface to the customer, there are many companies in India and outside of India who have done this. So the RFQ gets generated, the drawings go to the customer. There is no wait state in between. This is a classic example. Next is embedding the design calculations so that you are able to provide with different configurable designs to choose from, either to the design section, conventional design section, or if you're coming up with a new product development, coming up with all the calculations that are inside that, Excel driven, table design formula driven, whichever way you want it. And then you can put it in and you can develop the 3D model directly from that. Seeing is believing for your customer, and he is instantly able to see it. And then interrelationship between the driving and the driven dimensions put together, and then you get the drawings coming out. This is another example of a standards-based design which can be incorporated. So if the standard changes, you just go and change either the Excel or your coding or your macro and be done with it. So these are examples of how productivity can be increased, where the design engineer's value addition comes down quite a bit. His work gets done faster on other things where his concentrations are required as compared to these kind of mundane processes. Now, another example is you have a casting, you have a machining, you have configuration inside SolidWorks. You can put, for example, this is a brake rotor. Brake rotor, it's a disc brake rotor. It's a ventilated disc brake rotor, no-brainer technology. When I say no-brainer technology, because I have worked on this when I was at Ford Motor Company, and we have patented quite a few designs of this. We have done design of experiments calculation using this. We have automated the entire process over there. You get a design drawing coming out of this. Now, the casting person gets the casting drawing, the machining person gets the machining drawing, the process instructions flow forth. Everything comes out of these kinds of drawings. The design productivity is seen all the way till the last mile where the drawings are touched upon. So, if the design productivity is something that needs to be seen and felt by the consumers of the drawings that are produced by the design department. If they get the information what they want in actionable terms for doing their work faster, so that decisions can be taken faster by them, that is design productivity as well. It improves the overall ecosystem productivity in the organization. Remember, 85% of the cost of the product is determined by design. In that case, if we are able to automate the unproductive processes and concentrate upon those that give dividends to the company in terms of margins, in terms of profitability, that much more we are productive in terms of efficiency in the organization to get the bottom line profit. This is where these kinds of tools and technologies empower designers to think beyond the design space into the actual operations, customer satisfaction, as well as the end customer experience point of view. So, in rule-based design, when you are using flagship products such as SolidWorks, you have equation-driven design. I do not know drawings. I do not know macro development. I do not know C, C++, Sharp, C Sharp, or VB.NET, or any other tools and technologies. I don't even know how to write a macro inside Excel. Then equation-driven parameters can be put, and you don't even have to open SolidWorks. You can edit the text file, and the model and the drawing will get generated automatically. Next one is spreadsheet enabled designs using Excel. Third one is macros generated as you saw. Then API, full-fledged knowledge embedment using API, the application programmer interface inside SolidWorks that is so versatile. It is used. You will not believe it. One of our customer uses for development of a complete power plant in 45 minutes. I repeat, in 45 minutes. This was done not today. This was done in 2009, 2010. And then the design library is there for people who do not know how to use these automation tools. Use at the sketch level, use at the feature level, or the part or the assembly at the drawing level, either any one of them, because at the end of the day, drawing is most important for you and for the consumer subsequently down the line. How much ever we put in 3D, finally the 2D output matters, even for IBR regulations. And then you have the template-based driven, the template activities. So if I look at the mouse travel of a design engineer in an organization, average the mouse travels 50 kilometers every month. Can you believe it? You put the mouse on the mouse pad and you start moving it inside SolidWorks, you have traveled 50 kilometers every month. If you want to reduce that and you want to improve, less mouse travel, less fatigue, more work to concentrate upon on the innovation side of the design, how to change things. These are the tools that are available as slave to you to adopt in your day-to-day engineering practices. Downstream, after you have developed the design, or you could be in tool design, where you get 3D models from customers in IGES and other formats. Now you bring in those and you develop the tools and dies. For example, this is a trim die. IGES file comes from the customer. The entire die set gets created within 15 minutes. This is complete knowledge of tool design embedded into the tool sets. It goes to the end customer's tool room where they have Tebis and use that software. take the NC codes out of it, it's done. So the same design engineer is able to work on servicing the requests of multiple customers during the same 8 hours of engagement at the office. In 24 hours, 8 hours goes in sleep. 8 hours is professional life. 8 hours is in personal life. We steal the personal life and we give it to the professional life because drawing deadlines have to be met. This is where productivity comes in for our personal life as well. Now, the next thing is verifying a design with embedded simulation. Your customer says, these are the considerations. For example, in this case, a leaf spring. Design data books carry leaf spring designs. What's the big deal about it? The sting stiffness, the spring stiffness rates are easily manageable. The number of leaves, the configurable designs we can put it. We have configuration, we have everything. Customers know it. But then what other value addition you can do? The number of leaves, the parabolic curvature of the leaves, how to arrive at those parabolic curvatures in terms of the heat treatment process that you go through further down the line can be simulated. The beaten life can be simulated. The effectiveness of the individual leaves can be studied. You can look at the parabolic deflections as it goes through the process of making so that you can optimize the parameters, especially on the amount of heat supply, the cycle time of that particular stage, the number of stages, and things like that. You can do the nonlinear deformation all at the tip or the touch of a button. So as a result of which, the knowledge which is available with individuals is now put to practice, and the drawing comes out after many exercises which have been done using design studies, come up with the final design requirements, the final drawing before it gets released to either customer for fitment on their vehicle in terms of 3D CAD geometries or in terms of downstream requirements in terms of process engineering. Everything gets done without the person coming into contact with the design team itself. Maybe a last minute validation or a cursory check on the drawing can be done by the design person for 2 minutes and then based on a checklist, and then he can sign off. But look at how the end to end from design all the way through validation and verification, all the way till sign off and the process subsequently down the line, everything can be captured if the design engineering team steps out of the design room and looks at the entire process with a bird's eye view and tries to improve the productivity so that people who consume your designs get without any wait states. That is design productivity. Now let us take a look at this particular example. You see this example here, wherein a particular component is going to be taken out of this unit, and its assembly looks like this. We'll go through the process of automating it using your equation editor, where I do not know anything in design automation, API, macros, nothing I know. So I try to do something, I start getting errors. Now I'm going to give conditional statements in my design. I'm going to embed all my knowledge into this in terms of my equations, which I'm putting and teaching it to dimensions on the models. This is no brainer, right? You can always do it either here or you can do it on your sketch, and you can link it to the sketch as well. You can put this together. But what is the good thing about this? When you start automating it, the design studies can be also automated downstream. And a family of products can be put together. Now, everything is going to be written in terms of your design equations right in there. This is what we are seeing over here. So everything is connected, and the item is going to be constrained based on pin diameter, which is the bottom component. Standardization can also be introduced into this. In addition to constraints with regard to the design space, you can put that together and you can save it as a text file outside. You see how it's being linked to every parameter over there, and then you can save it as a text file. Once you save it as a text file and link it to an external file, and you change the values in the external file, see that? You take the Excel file, it's just a simple text file. You take that and you put it in, and now you go back and look at, see, the pin is also constrained in assembly based on the same equations. It's all driven using the same thing. See that? The same file gets connected to both because the assembly is what we are looking at. This is just a simple example, and you look at it. See here, if you change it in the text file, the 3D model will get updated. Was any code written here? Now imagine this situation wherein now SolidWorks has the 3D experience platform. You have put this in your text file, which is sitting on the 3D experience drive. Your sales team or your distribution team across the country or across the world updates for every RFQ they get and push it into the system. You get the drawing directly over models in e-drawing for communicating with your customers. You are automating the process. Design is involved, but it's the white elephant inside the room. It's not white anymore. It's the most productive elephant. It is chugging along and it's delivering to the customers seamlessly. It's involved in every bit of the way. So this advantage of doing this is that not a single line of code was written. So intelligent usage of these kinds of tools and technologies, not doing it the hard way, but the smart way, is the essence of the paradigm that we need to build in terms of improving the productivity day to day, so that our personal lifetime is not spared for professional life. Take the case of the sheet metal example. You have different configurations. You have got an order for developing the sheet metal component. You are putting the process layout. You are giving it to the manufacturing team downstream. So you create the configurations, you put everything together, you do it once, change the configuration, the entire process plans, everything gets done for the rest of the people. So in one go, you are able to get it done. One-time work for the design, multiple configurations. It could be 20 different products that your customer wants, cabinets, electrical panels, so many things. Electrical panels uses this extensively, sheet metal structures. Why do we need to keep building all the time? Then you give the front end of this to your sales team subsequently down the line and put it on your RFQ process. This has now the design input is there, but the design person is no longer getting disturbed. They can work on other innovative products, processes, so that for value engineering of the products and the processes, you can bring in. You see all the different configurations that are coming in. The same process go through. Only thing is the models keep changing all the time. And if one model gets changed and it has to be applied to a family of products, no brainer. Do it on the configuration and apply it to all configurations or selected configurations according to your customer's requirement and be done with it. So these are examples which you can leverage upon, technologies which you can leverage upon, specifically from a business point of view. Now we are looking at a validation specifically from a stress point of view, that you want to design a set of products based on a target value for stresses, von Mises stresses, let us say, so that this is a simple example we have told, but it's going to become more complex as we go further during this presentation. I'm only showing you all the different ingredients that you can use, and then I will show you the big picture, where hardcore engineering comes into picture. So as you go through, you fix the parameters, you establish the sensors and say, monitor these areas and do the design studies. And the software is put to work. Your multi-core Intel processor or the AMD processor that you are using on your workstation is being put to use. And as you do it, it is interactively doing every one of those design scenarios, and it comes up with the most optimal design and recommends the same for you. Now, it could be weight-based, it could be performance-based, it could be any one of them. And this is exactly where the power of technology is leveraged upon, and you do the static analysis for that and then get the optimal design and report it to. It is passed. This is just a simple example to show you. Even very complicated designs are being done by our design engineering team in our office as well as by our customers. Now, the next thing is now you translate that into a DOE, a design of experiments. The design people can leverage upon. You define the objective of the process, set the target values of the performance on a continuous scale preferred, enumerate the design parameters affecting the process, and look at the cross correlations between them using a scatter diagram, and specify the variation for each parameters in terms of levels, and then develop the orthogonal arrays for parameter design with number and conditions for each experiment. See how DOE gets jammed in, it's seamlessly assembled into your 3D model with the SolidWorks. Then conduct the design of experiments using the completed array to collect the data on effective performance measures, and then complete the data analysis to determine the effect of the individual ones. You can do it for masses, you can do it for dimensions, you can do it for simulation data, what we have seen earlier. It can either be used for evaluation or it can be used for optimization. When you use it for optimization in terms of cost, time, and quality, your company benefits. When you do it in terms of life-based designs, your customer benefits. Your company also benefits in terms of reduced warranty costs. The customer has a beautiful experience with your product that he becomes a repeat buyer for your products and technologies. So take the case of this example, a pump developed for a particular application. You know what the parameters are. We have taken a couple of three factors here, two responses that we are looking at. And then we do the DOE with all the 17 variables, 17 DOE experiments. We conducted using the design study, which you saw in the earlier slide. And then you record the response observations. You do the response surface analysis study. And then for the 17 experiments, and then you come up with the optimality of the values. You can look at this for the effect of your tolerances on your design as well. You have simulation, you have this, everything coming in together in one unified domain for you to leverage upon so that your productivity increases exponentially and the customer's value to the customer is unmeasurable. Now, if you look at it, this is an example of an API-based design productivity improvement. It could either be at the RFQ stage or it could be at the finished product stage, where you automate everything coming based on, again, text values given here. The 3D model and the 2D drawings get updated. In one customer's case, the application engineering was taking 25 days to develop the RFQ proposals, primarily because it was taking that much more time. And imagine a customer giving an inquiry, and after 25 days, you give him a proposal. How does the company reflect in terms of efficiency for the end customer's perception? That company automated it, and they were able to eliminate the downstream errors coming as a result of this. And they were able to put things together. This is an example, classic example of the full-blown API. You saw the model getting resized and the dimensions getting cleaned up. Because most of the time people spend a lot of time in cleaning up the drawings from 3D, right? This tool was done, finished. Now, the advantages of automation in summary is that you deliver superior products adhering to standards. You do an economic efficiency of the processes which deliver, and your cost comes down. Accelerated workflows elevates the precision in your organization in terms of achieving the goals and targets. Flawless drawings can be developed and released. What went wrong and what went right can be easily taken and automated as a part of your knowledge-based engineering activities in the organization, and it empowers effective collaborations between teams in the organization. What I've shown is a bird's eye view of what we do and what our customers do in terms of developing newer products to market technologies. And this gives you a very important value analysis that you achieve as a result of doing these productivity enhancements in your organization. It removes the unproductive tasks, addresses the voice of the customer effectively. In fact, you can attach it to your house of quality as well as to your DFMEA for risk-based engineering mitigation. And then you have improving your product performance and quality and increasing the market share. This gives you a bird's eye view as to how you can improve your productivity, design productivity using SolidWorks. I hope this presentation was useful for you, informative for you in terms of design automation, design verification, process automation that we do for our customers do by themselves by investing in these tools and technologies. I leave the floor open for any questions that you may have as a result of this to seek clarifications on this presentation and how we can engage forward. I leave the floor open to questions. Please type your questions in the chat box, and you can provide it to the presenter, and we will be in a position to answer the same. Oh, it's there. Okay. Okay. How to export and import the DLL format for using a macro if it is possible? See, macro is run on the screen. Is run runtime. Macro is runtime. While you take it into your Microsoft Visual Studio, and then you can add it to your DLL, and then you can put it together. If this doesn't answer, then I need to get offline with you and take it forward. Any other questions? See, the most important thing here is the design productivity is seen and felt in the rest of the organizations as a result of the quickness with which the design engineering team responds because of these kinds of productivity enhancements in the processes. Using DLL, it doesn't work, then I'll have to take it offline and find out where the glitches are, and then it could be a security problem. We do not know whether your macro also uses Excel. So more information is required. We can take it offline, and I will be glad to answer. Can we record macros while modeling? Then we can modify macros to change the dimension. Yeah, this can be done as well. And you can also include, yes, that's how, in fact, one of the customer developed power plant engineering aggregates based on using the macro and then taking the code and then getting into actual code development using the macro information. So it speeded up their process. They did it. Some people do it using this because it is quicker, it's faster, and it is driven by the user's behavior. So they did that, and yes, it was done. And while recording macro, the dimension is not recorded. How to work on this? Need extra coding. I placed the dimension on the correct locations in the drawing sheet. See, the correct locations in the drawing sheet, there are many ways of doing this. This will require a lengthy explanation. There are many ways of doing this. But as a user, if you look at it, you can select the location on the sketch itself. And then every time you create the 2D drawings, it will not change its location. It will stay right there where you wanted it. So you don't need to write a code for doing this. But then there are situations wherein you need to do the drawings using algorithms. We have done that for quite a few customers, and we'll be happy to engage with you to see how we can help you to do this. Good evening. Can we able to optimize different materials for part model to check the mass properties? See, mass is given as one of the targets. When the mass is given as one of the targets, you can go through with the mass as the target, and you can do the optimization. Mask is directly tied to your cost as well, right? Finished product cost. When the finished product cost itself comes down significantly, see, we have been working with a lot of different customers. One example is we have used these tools and technologies to develop lightweight electric vehicles. And today, long years ago, now I can tell it because it is out there in the market and the customer has publicly acknowledged it. We have done optimization in Skyline buses for Aicha. We took 100 kilograms out of the bus using these tools and technologies more than 20 years ago. And the bus still lives. It is finished product weight that we took out. Yes, it can be done. Issues while recording macros like mouse movement and option selection are recording in macros. Difficult to say. Each technology has its own advantages and limitations. If you want rapid code development, then you can use the macro. If you want to develop serious, very large codes, then we would recommend you to go the regular route, regular API route, and then you should be in a position to do. How to do DFA and DFM in process automation? Design for assembly and design for manufacture. I do not know whether you know this PRIMA matrix, prioritization matrix for manufacturing and assembly. You can use that approach to automate it. You can use the spreadsheet. You can use that to come up with the decision making and then use that as a guide inside. Remember, there is a design binder inside SolidWorks. You can embed that Excel sheet based on the PRIMA matrix inside. And then once you have the Excel and SolidWorks right inside, you can drive it right there. There's one way of doing it. How am I improving SolidWorks tool easy to use? How can I assume the question is, how can I use the SolidWorks to make it easy to use? You can combine commands to create new commands and automate the tasks. This is one example. And you can create your own menu systems inside, which use either the macros or the DLLs or a combination. And then you can come up with methodologies to develop productivity tools. In fact, at EGS, we develop quite a few productivity tools, especially in drawings for customers. So we can look at your requirements and we can try and address them. And next one is SolidWorks. Does it support DFMEA? Is based on a standard. So, for example, you have your SOD, right? So you can take your DFMEA and integrate the template provided for DFMEA according to the latest standard, embed it inside your SolidWorks model, and attach it to the dimensions to say the severity, occurrence, and the detection values have significantly been changed to lower levels, thereby demonstrating mitigation, risk mitigation. Once you bring in the Excel sheet, it goes along with the 3D model, right? So if you want, you can always password code it so that only the design team can view the DFMEA, because DFMEA contains the IPR and the proprietary considerations of the organization. But then it can be done and it can be put as a part of the process. In fact, some of our customers put checklists and put this inside the PDM. So when the people check in the file, if the DFMEA document is not attached, the check-in will not happen. Similarly, basic checks on the drawings can be done before it is put into the PDM, and it follows the workflow subsequently down the line. With one of our customers, we do it. They have over 2,000 design engineers, and every single time the model is checked in, it goes through a process of verification of all the errors which are there in the model, and it will not allow the person to check in if the models have errors. So a lot of different things can be done. Do you have any PBA course Oh, we do provide time and again. We provide courses on SolidWorks automation using the automation tools that are provided inside SolidWorks, including API. We provide those training. In fact, we are known for providing API training. You can let us know if you do not have any knowledge in API, but you are having a bent of mind for doing the programming. I would suggest you go through the training program that we offer for API. It's a 3-day program. You can join our experts who develop softwares inside SolidWorks. They will be the course handlers and they will do this with you and address first. They will look at your requirements as to what you want it. Then they will comfortably take you through the process so that you can become an expert in using API inside SolidWorks for leveraging on the productivity capabilities. We are doing top-down assembly, taking reference from one parent part. We need to automate this assembly and drawing. Is this possible? Absolutely, it is possible. In fact, even for large assembly, we help customers to write codes and we provide them with specifically for this thing so that when they go for design review meetings, when they go for um, uh, customer interactive meetings, their responses are faster because these are huge assemblies that we are talking about. Power plants, vehicles, so many different types, machineries, so many different types, especially in machineries. Yes, it is possible to automate this. And we can sit with each and every one of you who are interested in automation and go through this process. Automation is empowering the design engineers to be more productive, not to remove design engineers from the team. More designs can be done by the same team. In fact, one of our customers was having a turnover of 185 crores. Today, they have crossed 400 crores. They had a design team of 40 people then. Today, they say they have the same design team of 40 people. But what about the turnover and the profitability of the organization? I'm giving you metrics, exact data, but I can't tell you the name of the customer, but I can tell you this. Why is that I'm saying this? Companies which is aspiring to grow, if design is able to spin out many products and technologies in a finite time that is being provided to us, they win hands down. It is success all the time. So you can do it. Yes, it is possible. My suggestion is you don't look at it only from a design point of view. Look at it from the point of view of voice of the customer or RFQ all the way till invoicing. Look at all the touch points of design where the consumption of the drawings or the 3D model takes place and see how you can reduce the bottlenecks and improve the productivity. Then you will get a bird's eye picture. One part file is created in so much of configurations, but in some time they can. You want see there are two things now that you said step. There are two things. Step itself as AP 203 and 304, right? And then you have AP 40. If I remember right, I forget the number. Step has a methodology by which you can write the entire configuration into one file itself. But unfortunately, most of the CAD companies which open the step file do not recognize the configurations. So if you may write it out, but then other people may not be able to read it. Of what use is it? But you can use the SolidWorks automation to write out the step files for each configuration out separately so that if you have 100 configurations, you can take out 100 files in one go. Yes, it can be done. We use linear stackup in studies. How to prepare a design review for a customer, to the customer. How to prepare design review for the customer. Design review comprises of many things. It all stems from the voice of the customer. So if you take the voice of the customer in an Excel format, embed it into the assembly file, let us say, the layout assembly file, and go through each one of them and show it to the customer, linking your embedded Excel file inside your assembly or inside your parts, and then you go through step by step. The customer sees the voice of the customer being addressed, and then you satisfy the customer. This is one thing. Second one is standards-based design. In standard-based design, it is easy for you to generate reports, and you will be in a position to get it out. Next, in SolidWorks, we do linear stack-up study. Can we use GD&T also in stack-up study like flatness? See, flatness is a level 2 control. Size controls flatness. Size controls form unless otherwise it is refined using a form tolerance. Since you have already considered size, it is general practice not to include the flatness because the size it is a part of the size element form. See, please understand. If you don't provide flatness on a drawing and you have given a width type dimension and you use plus or minus x plus or minus y, the plus or minus y entire value can be taken as the flat form control unless you refine it using form elements. But then if you are doing using ASME standard or wherein it says perfect form at MMC, or you're enforcing it in the ISO standard using perfect form at MMC, then again, you don't need to consider. But if you put the independent symbol in ASME, or it is by default independent in ISO, then you need to consider it. Otherwise, you don't need to. You can take it and you can drive your Excel-based, spreadsheet-based tolerance stackup, or you can use the premium version, which also has the linear stackup inside it. While I'm creating drawings for assembly drawing, which model was created under configuration, not able to link the drawing with the second model. I do not know which PLM you're talking about. We had a case wherein we were asked to do an automation. You won't believe it. Customer, before using SolidWorks, they were using another division was using Siemens PLM and Siemens NX, and this division was using SolidWorks. So they wanted the custom properties of the Siemens NX file to go into Siemens PLM and come and populate the same thing inside SolidWorks, folks. This was asked to the PLM provider and their service provider. They pointed the hand. No, actually it was Innovia PLM, 3D Experience Innovia PLM, Siemens NX 3D model containing the custom properties, and downstream consumption was using SolidWorks. The 3D models in Siemens NX was being used in SolidWorks, and it has to be checked in back into the 3D Experience platform. Were we able to do it? Absolutely, we were able to do it. We took it as a project and challenge, and we did it. If you are using SolidWorks PLM, then we should be in a position to do it. We will take this offline and we will see how we can help you to do this. Any other questions you have, ladies and gentlemen? Every month we are having the Design Without Error series. And next month we would have one more around the similar times. So we thank you for the time taken and among your busy schedule. And we look forward to seeing you again next month. We hope this is a productive session. You can leave your feedback or get in touch with us on info or on the mobile, or visit our website egsindia.com and see the different videos that we have. We have a channel. We have also a WhatsApp channel which you can subscribe to, and so that we give productivity videos like this. Because knowledge sharing is one of the biggest motive of these kinds of programs for our customers and people who want to become our customers. We would be glad to help them. So please ensure that you subscribe to our channel both on YouTube as well as on WhatsApp. On WhatsApp, we have a channel that is even more convenient. If you turn on notifications, you will get the next webinar right then and there. Please participate so that this is an announcement question for all of you. Have a wonderful day and week ahead. Thank you.